Hello everyone, welcome to the lecture on soil acidity and alkalinity. We will talk about soil acidity for a couple of our lectures. At the beginning, we need to understand what is soil pH before we understand soil acidity. The word pH is derived from the word pisces de hydrogen. The meaning is strength of hydrogen ion concentration. In other words, it is all about how many hydrogen ions are present in the particular soil. That makes the soil acidity. Meaning more hydrogen ions means more acid. But it could be a little bit confusing. When we have more hydrogen ions, we have more acidity but low pH values. Therefore, soil pH is the measure of the acidity and alkalinity of the soil. 7 is the neutral one. As we go less than 7, that would be acidic. As we go more than 7, that would be alkaline. Here are some examples. For example, beer would be less acidic as compared to battery acid. Same way, soap solution would be less alkaline as compared to caustic soda. Though this figure says that the ideal pH for plant growth is in between about 5.5 to 8, this range would differ from literature to literature. You may find this range between 5.5 to 7 in some literature, while some will say 6 to 7. But the overall meaning is majority of the plants like neutral soil pH, that is close to 7. We classify soil solution pH according to its strength of the acidity. We have about 6.6 to 7.3 as neutral range. Again, this can be different from one literature to another literature. Then we have slightly acidic, medium, strongly acidic, very strongly acidic, and extremely acidic. There are not too many soils below this level. It is extremely acidic. Same way, we have mildly alkaline, moderately alkaline, and strongly alkaline. And it is hard to find the soils that are having soil pH more than 9 or so. This is the figure 1 from the textbook. In this figure, we can see the relationship between the hydrogen and hydroxide ions. An acidic soil has more hydrogen and alkaline soil has more hydroxide ion. In other words, as the pH increases from 4 to 10, the hydroxide ions also increases continuously. In contrast, as the pH decreases from 10 to 4, the hydrogen ion increases consistently. This is the figure 2 from the textbook, and here are some values, the pH values for familiar substances at the top of the figure. And at the bottom of the figure, we can see the different kind of soils that will help us to describe the soil acidity using different substances. We can see battery acid, the very acidic, and the drain cleaner, very alkaline, while pure water is the neutral one. In this figure, milk is placed on the right hand side of the pure water, meaning that milk is slightly alkaline. But in reality, milk would be slightly acidic because milk contains lactic acid, and lactic acid makes milk slightly acidic. Therefore, I believe milk better fits on the left hand side of the pure water as compared to the right hand side. Anyway, below 7 we have the humid region soils and forest soils. Above 7 we have the calcareous soils and sodic soils. Calcareous soils contains more calcium carbonate, while sodic soils contain more sodium, and both make the soil alkaline.
We often hear about pH, but what is it really? It's the measurement of how acidic or alkaline a solution is. And this is important for a lot of different reasons. In water gardens, it can affect the health of our fish. In our own bodies, it can affect our health as well. Typically, you see pH referred to as a number from 0 to 14, 0 being the most acidic, like battery acid. 1 is a little less acidic, but it's still considered an acid, and this would include your stomach acids. 2 is lemon juice, and 3, we've all heard about the corrosive nature of soda pop. 4 is tomato juice. 5 is black coffee. And 6 is plain old milk. Also at 6 is your own human saliva. Now at 7, this is the halfway point between 0 and 14. And this is the sweet spot for a garden and a lot of different things. This is where pure water resides and also our human blood. At 8, we have egg whites, and these are transitioning more into alkaline solutions. At 9, we have baking soda, and 10, we have milk of magnesia, which is an antacid. So we often take this to help balance the stomach acids. At 11, we have ammonia that's used for cleaning, as well as 12, we have soapy water. 13, we have a lot of our bleaches, and then finally some of our most corrosive bases is our drain cleaners at 14. So what does all of this have to do with gardening? Well, just like our own bodies that can get upset when our pH is off, so can our plants in our garden. So for more information, we're going to go talk to the expert. Dr. Zhang, thank you for joining us again. We're going to talk about pH. Can you explain a little bit of the science behind pH?
Well, I'll be happy to. pH is one of the most important tests in the routine package we talked about the last time. So pH basically is measuring the soil acidity or alkalinity in the soil. It's very important. It's just like our blood pressure. It can't be too high or too low. Basically, the acidity is the hydrogen ion in the soil, okay? It's very low. Typically, it's like 0.00001 molar, right?
Okay.
Or 10 to the minus 7. That's how low it is. Well, it's very tedious to write all this amount. So people use the symbol negative log to express that. That would equals 7. So they put a pH there, pH 7. This is how pH is expressed.
Okay.
In the laboratory, we do all this conversion. We tell you your soil pH is.
Okay. So you give us whole numbers to work with.
Yes. Typically, it ranges from 0 to 14. However, most plants like the neutral range, 6.5 to 7.